All right, hi guys, it's Dr. Ihrig here, and actually we've already gone over exponential growth and decay on a previous slide, so we're going to talk about that a little bit quickly, and then we're going to move on to the word problems. So just as a reminder, if the number inside the parentheses is greater than 1, it's going to be growth. So 2 is greater than 1, it's going to go up. If the number inside the parentheses is less than 1, then it's going to be decay. If it equals 1, which it won't, it'll just be a straight line. Okay? All right, moving on. So let's take a look at this first word problem. Since January 1980, the population of the city of Brownville has grown accordingly to the mathematical model of y equals and then that. You know what I'm going to do? Just for kicks, let's put in that function, even though we're going to have to really, really zoom out. It's always good to, remember, use this AB button to get the exponent in. It's always, let me move this so you can see it a little bit better. It's always good to pull that, to type in anytime you see a function. 1, it gives you practice. But then 2, it's just super helpful. So let me type that in one more time. So I've got y equals, or we like to write f of x as a function. So I've got 720,500, parentheses 1.022, and what I pulled out to show you is this AB button allows you to put in the x. Now clearly I can't see the graph, so you're going to really have to keep scrolling. You're going to have to scroll forever and ever because this graph is in the millions. But there, that's what we're looking at, okay? We can see it kind of goes up, and eventually it's going to cross over at 720,500 is where it'll finally cross over right there. But I want you to think, okay, it goes up, it goes up. So what does this information mean? Well, this number, remember, is always going to be our initial value, our starting point. So if we're talking about home prices, that's the starting point of the home price, or the population, not the home price, population. This is how much it goes up. Now, remember that this decimal represents a percent. So we take the decimal point and then we multiply it by 100, or move the decimal 2 points to tell you that it goes up at a rate of 2%. So it says, what would the world population be in 2000 if the growth continues at the same rate? Well, here it's 1980. So if we're at 1980 and we're going to 2000, we have to think about how many years have passed. So what I'm going to do is I'm just going to go over here and I'm going to do 2000 minus 1980. And that tells me that 20 years have passed. Now, because of that f of x trick I showed you, all I'm going to do in here is put f of 20. And that's the answer. That number, 1,113,401. And I'm not going to round up. You can't have 0.75 of a person. Using this model to predict about when the population of Brownville will first hit 1 million. So now what I'm going to do is I'm just going to type in f of x equals 1 million. And then we're going to have to scroll and see when they intersect. So I'll click right here, and it's so hard to see where they intersect. Keep moving, right here. Okay, so notice how we had to scroll in to see it, but the intersection is the answer. So this value stands for how many years? So it'll be about 15 years. Because we're looking for the intersection. So all I did was type in f of x equals 1 million, and then we just looked for where do they intersect. All right, let's take a look at this next problem. If the half-life of medication for the drug is listed below, where R is the remaining, M is the initial dosage. Okay, it says a 200 milligram dose of Advil is taken at 1. How many milligrams of the medicine will be in the body at 6? So 1 to 6 is how many hours? 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock. So we know that T equals 5. And the initial dose is 200. All we're going to do is go over here and have my f of x. And I'm just going to type in my initial dose is 200, 0.5. And then it says t to the t halves. So we're going to use this little AB button and then do x over 2 as my fraction. So this is my problem right here. And then it says when t equals 5. So I'm just going to put f of 5, and that's what my dose is. How much will be remaining in my body? About 35 milligrams will be left. If a 200 milliliter dose is taken, how many will remain 12 hours later? So instead of doing T5, I'm just going to do f of 12 because I want 12 hours later. 3 milligrams. I'm telling you, it's so easy when you use the formulas and you use the calculator to help you. Don't worry about the graph. You can even turn the graph off. The graph doesn't matter. We just need the conversions. All right, your new computer cost $1,500, but it depreciates, means it goes down 18% a year. Remember, when it goes down, we have to subtract that decimal. So that's really going to be 0.82 inside my parentheses for my function. So it starts at 1,500, and then you can write it like this if you want, and then you have X years. So I'm going to go back to my graphing calculator and type in my f of x function. My starting value is 1,500. You could simplify it, or you can just put in the 1 minus. Doesn't matter. And then we hit that to the x. So if I zoom, I'll be able to see it somewhere. We're just in the 100,000, so it's really hard to see. Actually, let's just put 0.82 in. Oh, that's why I have it turned off. All right, so there's my graph. We can see that it's going down. Okay, and I'm just scrolling in to get smaller. There we are. So it wants us to say, okay, what's the computer at 6 years? F of 6. That's how much the computer is worth, $456. How long will it take for the computer to be worth close to $0? Honestly, this is the one I would probably scroll in, or you can just do f of x equals 0. And we'll just keep scrolling and scrolling and scrolling. I mean, right here it's worth 49. Let's see. We need the green graph. Right there it's worth $48. Oh no, we're looking at the y value. I mean, I would say about 50 years. I don't think you're going to be exact. I mean, at 48 years it's worth 10 cents. So what does close mean? I would say about 50. All right, this is Dr. Ihrig. Thanks for watching.